Hey, welcome back. Boy, we're making our way through this chapter. We're about to enter into lesson 1.7. Still talking about real numbers, but now we're going to focus on properties. A lot of them you've heard before. Those of you who have had me, I've taught them before. The commutative property. We're going to review the associative property and how to tell the difference between the two. We're going to talk about identity, the additive identity, the multiplicative identity. We're going to talk about inverses, the additive inverse, the multiplicative inverse. And then we're going to finally close off talking about the distributive property. You've seen all of this before, so hopefully this will kind of shore up and just, kind of dot some I's and cross some T's for you. So let's go ahead and get started. All right. We're going to start our properties of real numbers for addition and multiplication with the commutative property. The commutative property says you can change the order. Okay? The order can change, all right, without changing the answer. The order can change without changing the answer. So here in example A, we can add A plus B, which equals B plus A. So if we have 3 plus 5, that's going to be the same thing as 5 plus 3. 8 is 8, right? Doesn't matter the way you order your numbers when you add them or multiply them, okay? Notice in this example, negative 8 plus 5 is the same as 5 plus, what would this be? A negative 8. Okay, you can change the order. The commutative property says the order can be changed. So if you're comparing two sides and the orders of the numbers have been flipped or exchanged or changed, then you've used the commutative property. The associative property says that the numbers themselves haven't changed the order, but the way they're grouped, where the parentheses are located, the way the numbers are grouped has changed. Okay? Even though it's been changed, it doesn't change the answer without changing the answer. So in example A, I can go A plus B, in parentheses, so I do that first, plus C, and I'm going to get the exact same thing as if I add B and C together first and then add A to that. So down here, 8 plus, and in parentheses, negative 1 plus 4 is exactly the same as 8 plus negative 1 and then adding 4 to that. Okay? So I can change the way the numbers are grouped. Notice that I'm not changing the order of any of the numbers. This works for multiplication as well. A times B, in parentheses, times C is going to give me the exact same answer as A times, in parentheses, B plus C. Notice how I've changed where my parentheses are. I've changed what the groupings are, okay? So, I can't read what I have down here. That's all right. We'll do some in the examples. Okay. When distinguishing between commutative or associative, my recommendation is look at the order. Look at the order of the numbers on the left and compare it to the order of the numbers on the right. If the order has changed, then you've used the commutative property. So, for instance, 8 plus 5 plus 2, if that is set equal to 2 plus 5 plus 8, notice that the order of my digits has changed. The order of my terms has changed. 2 was last here, now it's first here. So that means I've used the commutative property. I can change the order that they appear, okay? Now, the associative says the numbers are going to be in exactly the same order on both sides of the equal sign, but the grouping symbol has changed. The grouping symbol has changed. Okay? So this is going to look something like 8 plus 5 plus 2 is equal to 8 plus 5 plus 2. Notice that 8 is first on both sides, 5 is second on both sides, and 2 is third on both sides. The order hasn't changed, but look how my parentheses have changed. That means that I've used the associative property. Okay? Sometimes both the order and the grouping can change. So I can have 8 plus 5 plus 2, and that's going to equal 2 plus 8 plus 5. That's why with addition and subtraction, a lot of times you won't even see, addition and multiplication, you won't even see parentheses like this because it doesn't matter the order that you do it. Okay? All right. Determine which property, commutative or associative, or both, has been applied. So on example A, I have 2 plus 4 plus 5. 2 and then 4 and then 5. Okay, now look over here on the right side. 2 and then my second term is 4 and then my second term is 5. My terms are in exactly the same order. Commutative property has not been applied. Now look at how it's grouped. This one, 2 and 4 are grouped together. Here, 4 and 5 are grouped together. So that means I've used what? I've used the associative property. Okay? All right? Try B and see what you come up with and then come back. All right, welcome back. I have 6 parentheses 3 times 10 equals 6 parentheses 10 times 3. All right? I go, my first term is 6, or factor is 6. My second factor is 3. My third factor is 10. Here, my first factor is 6. That's the same. My second factor is 10. Oh, that's not the same. I've changed the order of my factors. So that has to be the commutative. Okay, I like to think of commutative. To help me remember this word, I'll say when I commute somewhere, I change my location. So my terms or my factors have changed location. All right. C, I have in parentheses 8 plus 1. Then I'm adding 7 to it. On the right side, I have 8 outside the parenthesis plus 7 plus 1. Okay, my terms have changed position. Notice that these two are not the same. So I've used the commutative property. Okay, then I've changed how I've grouped. All right, so that's also the associative. So this one is both. All right. Okay, our next set of properties are the identity properties. And the first one is the additive identity property. Can you think of one number that when you add it to any other number in the whole universe, it doesn't change the number that you've added it to? It's 0. 0 is when you add 0, the number is unchanged. A plus 0 is still equal to A. Negative 8 plus 0 is still equal to negative 8. So 0 is the additive identity because you get the identical number that you added 0 to. Okay? The multiplicative identity is the one number in all of the universe that when you multiply it by any other number, you end up with the other number, and that's 1. 1a times 1 is equal to a. You haven't changed it, okay? Negative 2 times 1 is still equal to negative 2. 1 is the multiplicative identity because when you multiply 1 by any other number, you get the identical number. Okay? All right? This multiplicative identity, you don't realize it, but you use it a lot whenever we simplify fractions or whenever we write fractions in equivalent forms. All right? And we're going to do that right now. Use the multiplicative identity property to simplify or write equivalent fractions. Okay, now watch what we're going to do here. Okay, 49 is the same as 7 times 7, right? 35 is the same as 5 times 7. Now I'm going to split this up. I have 7 over 5 times 7 over 7. 7 over 7 is just a fancy way of writing 1. And any number in the universe times 1, that number is unchanged. It's how we simplify, it's how we reduce. We use that multiplicative identity, all right? Why don't you guys hit pause for a second and try the B on your own. All right, welcome back. 6 times 6, I can write that as, or 36, I can write that as 6 times 6. And 48, I can write as 6 times 8. All right? Now I can split this up. 6 over 6 times 6 over 8. Notice that this is a fancy way of writing 1. 1 times 6 over 8. 1 times anything is that anything. 6/8, and we're going to reduce it to 3/4. Okay? Actually, we could go a step further. We could do it even more precisely. 6/8 is equal to 3 times 2 over 4 times 2. Here again is your multiplicative identity, 1. So you just end up with 3/4. Okay? Now, we also use this property when we're writing equivalent fractions, like when we have to find a common denominator. All right? Watch what we do. Does 4 go evenly into 24? Yeah, it does, 6 times. So that means I have to multiply 4 times 6. Well, if I multiply the bottom times 6, I have to multiply the top by 6, right? Okay? Look at what that is. That is just a fancy form of the number 1, okay? We're just using it in the opposite way so that we can get a common denominator. So 3 times 6 is 18 over 24 plus 5 over 24. And 18 plus 5 is equal to 23 over 24. All right? Okay, again, hit pause and do D by yourself. You're subtracting there, okay? Hit D, or do D, and come back. All right, welcome back. All right, does 8 go evenly into 24? Yes, it goes in 3 times. So I'm going to multiply the bottom by 3. If I multiply the bottom by 3, then I have to multiply the top by 3. Do you see how we're using this identity? And we didn't even realize that that's what we were doing. A lot of math is like that, all right? So this fraction over here becomes 9 over 24 minus 5 over 24, okay? And that gives me 4 over 24, okay? Now I can write this as 4 times 1 over 4 times 6. Again, here's our magic number 1, our identity, all right? That's just 1 times 1/6 is equal to 1/6. See how we use that identity property and we didn't even know what it was called, right? Okay. The next properties we're going to talk about are the inverses, the additive inverse and the multiplicative inverse. Let's start with the additive inverse. The additive inverse, okay? Additive inverse, and we've touched on this before, a pair of numbers that when you add them together, they have to be 0. Think of absolute value. This is where we saw the additive inverse, okay? You have to add opposites together to get 0. So A plus, and the opposite of A equals 0. A and the opposite of A are additive inverses. Why? Because they're a pair of numbers that add to 0. -8 plus 8. This one is positive, negative. This one is positive. You add them together and you get 0. Just like so. Okay? So any number that are opposites. Notice that each are 8s, but one is negative and one is positive. Here, each are A's, but one is positive and one is negative. They always add to 0. Okay? Now, with a multiplicative inverse, you're looking for a pair of numbers so that when you multiply them together, they become 1, or the identity, okay? The multiplicative identity. And those are the reciprocals. The reciprocals, okay? Not the opposite reciprocals. We're not flipping the sign. We're just flipping the fraction. So A times 1 over A. Well, if I multiply that out, I get A over A. Anytime you have the same number in the numerator and the denominator, what do we say that equals? 1. All right? So A times 1 over A gave me an answer of 1. So these two are multiplicative inverses. Okay? Because their product is the identity. Here, the additive inverses, the sum is the additive identity. Right? Now I have -2 times -1/2. All right? Negative times a negative gives me a positive. And then if I multiply straight across, I'm going to get 2 over 2. This is the same thing as 1, positive 1. All right. The distributive property. This is the final property that we're going to look at. All right, and then we're going to do a bunch of examples, okay? The distributive property says that, notice how you have a number outside the parenthesis. I have a number outside the parentheses. In order to correctly multiply this, I have to multiply both inside, or however many inside terms there are. If there was 10, I'd have to multiply all 10 of them by whatever number is on the outside. That's how I get A times B plus, because that's a plus, A times C. You're multiplying every term on the inside by whatever number is on the outside of the parenthesis. Okay? This is the only property that combines addition or adding the opposite and subtraction. Okay? It's a process of changing a product to a sum or difference. All right? If we have A times B plus C, we did this up here, we get A times B plus A times C. Now do it with numbers. Okay? 7 times 3 plus 2. Okay? If we use the distributive property, we have to go 7 times 3 plus 7 times 2, which equals 21 plus 14, which equals 35. All right? Now, if we use our order of operations, all right, we would have to do what's in the parentheses first, right? So let's check our answer. 3 plus 2 is 5. What's 7 times 5? 35. You see how you get the same answer? Exact same answer. Let me make sure I'm visible. Okay. Works the same way if there's a subtraction sign in the middle, okay? Works the same way if there's a subtraction sign in the middle. Okay? And notice now I've put my outside behind it. Doesn't matter. I'm still going to go A times C plus B times C. I did exactly the same thing because it doesn't matter if I write this as CA minus CB. It's the same thing. Okay? Let's do it with an example with numbers and letters. I'm going to go 3 times 7 minus 3 times x. 3 times 7 is 21 minus 3x. And I have simplified it. I have correctly distributed. All right. Use the distributive property to rewrite the expression. Okay, so here we're going to use the distributive property. It's not the only way when there's just numbers only. Okay, and you can check it the other way. Right? So let's try A together. I'm going to go 5 times 9, 5 times 9 plus 5 times 6. Now I have to do multiplication before I do my addition. 5 times 9 is 45, plus 5 times 6 is 30. So I get the answer of 75. Now check it. What if we added 9 and 6 together? We would have got 15. What's 15 times 5? 75. We get the same answer. All right? All right. We're learning to do it on numbers, what we're used to, so that when we get down and we have letters, we know how to do it. All right? All right, you guys try B and come back and see if you got it right. All right, welcome back. I'm going to go 4 times 3 plus 4 times 7. 4 times 3 is equal to 12 plus 28, and that's going to give me 40. All right, let's just check it. 3 plus 7 is 10. What's 4 times 10? 40. You see how we get the same answer? One way we use the distributive property. One way we use the order of operations. All right? Okay. Now we have variables in here, and we can only use the distributive property because we don't have values for x and y. All right? So we're just going to keep with the same thing. We're going to multiply 4 times each and every one of these terms on the inside. What's 4 times x? 4x. What's 4 times 5? And then what's 4 times y? So we get 4x plus 20 plus 4y. And we could rewrite it by the commutative property as 4x plus 4y plus 20. Because all I did was change the order of my terms. Okay? Why don't you try D on your own and come back and see if you got it right. Be careful of that negative number. Remember, this is a sign flipper. All right? A sign flipper. Okay? Go ahead and give it a whirl, put it on pause, and come back. All right, welcome back. I'm going to go negative 6 times x. All right? And then I'm going to go negative 6 times y. And then I'm going to go negative times a negative. That gives me a positive 6 times z. Okay? You see how I did the sign flipper? This becomes a negative 6x because it's an understood positive in here. This positive y becomes a negative 6y. And this negative z becomes a positive. This is a sign flipper. Okay? E, 3 times k minus 3 times 9. So I get 3k minus 27. Why don't you try F? and then come back and see if you got it right. Okay, welcome back. 8 times 3 r plus 8 times 11t plus 8 times 5z. I just multiply my numbers together, all right, to simplify. 8 times 3, you could think of it as grouping them. 8 times 3 is 24r plus 8 times 11, 88t plus 40z. Okay. We can also use the distributive property to go the other way, okay? Look at this expression. I have 6 times 8 plus 6 times 2. Notice that 6 is being multiplied by both of these, all right? So I pull whatever is the same in each factor or each term, and I pull it out in front of the parenthesis. And then the other two I put in parentheses, and I put this addition sign in between. This is like what we've done with factoring out the greatest common factor, all right? So give B a whirl and see if you get it right, and then I'll do it with you. Look for what's common. I notice that I have a -3 that's common to both, so I'm going to put that outside my parenthesis, which is going to leave me 4 plus 8. Why is this not 4 minus 8? Because 4 and 8 are not being multiplied together. They're being added together. Okay? C, look for what's common and pull it out in front of the parenthesis. So I have 3 as common, which leaves x plus y. Just like so. Okay? Now D is a little bit more difficult. Try rewriting 8 as 2 times something. So I have 2 times x plus 8 is 2 times 4, right? Now I have a common 2. So I'm going to put that out in front of my parentheses. And then x plus 4 is what goes on the inside, just like that. That's called, I like to call it as undistributing, kind of like the uncola thing. But it's really the concept of factoring. Factoring is undistributing. Okay? We can also use the distributive property to remove parentheses. We are undistributing, okay? But it just, we tend not to think of it that way. But what you want to do is remember that if you have a negative with no number, you want to remember that that's a -1. So remember, if you can remember that a negative in front of parentheses is a sign flipper, then you are good to go, all right? So I have -1 times 7r minus -1 times 8, okay? -1 times 7 is -7r, and then minus -1 times 8 is minus a -8, okay? So this is -7r, and then I have minus a negative. So I'm going to add the opposite, plus 8, okay? Those of you that had me before, I've said this is a sign flipper. So it changes the sign of the 7r, it becomes -7r, and it changes the sign of -8 to become +8. See how we got the same answer both ways? Okay, why don't you try B on your own? Remember, you're multiplying by a -2, all right? So the negative is the sign flipper, and then also you have to do the 2. All right, welcome back. Negative 2 times negative 9w plus negative 2 times 2. Negative times negative is a positive 18w. Positive times a negative is a negative. 2 times 2 is 4. Just like this. Now look here, we're multiplying by a positive 4. No sign flipper there at all, right? So we're just going to just do our distribution. 4 times a negative x plus 4 times a negative 3y plus 4 times 6z. What's 4 times negative x? Well, that's nothing more than negative 4x. What's 4 times negative 3? That's nothing more than negative 12y. What's 4 times 6z? That's nothing more than 24z. Okay? Just like that. All right. I'm going to spend 2 days of an assignment on this, so you won't, tomorrow night, you won't have an additional lesson to watch. You can choose to re-watch this lesson if you like, if you need some extra refresher. But tomorrow in class, we're going to be working on this day one assignment. Okay. So thanks for listening. Thanks for filling in your notes. Remember to pay attention to your self-evaluations for watching the video and your practice problem set. So I'll see you tomorrow.